This section describes security design principles. The security pillar of the AWS Well-Architected Framework describes 7 design principles. Let's look at each one. First, build your security culture on the principle of least privilege. Only grant access to the data and other resources to the people who really need that access. Another best practice is to enforce separation of duties with appropriate authorization for each interaction with your AWS resources. By reducing or even ending reliance on long-term credentials, you can diminish your attack surface area. You can use temporary credentials and require identities to dynamically acquire them. In AWS, IAM is the primary service for permissions management. The service provides the ability to control user and programmatic access to AWS services and resources. The second principle is to enable traceability. With AWS, you can monitor, alert, and audit actions and changes to your environment in real time. AWS provides native logging as well as services that can provide greater visibility in near real time for your occurrences in your environment. Integrate these tools with your existing logging and monitoring solutions. Know what workloads are deployed and operational so that you can audit and ensure that the environment is operating at expected security governance levels and meeting required security standards. Several AWS services can help you with traceability. CloudTrail logs, AWS API calls, and Amazon CloudWatch provide monitoring of metrics with alarming, and AWS Config provides configuration history. Rather than only focusing on the protection of a single outer layer, apply a defense in-depth approach with other security controls. This means to apply security to all layers, such as your network, application, and data store. For example, you can require users to strongly authenticate to an application. In addition, ensure that users come from a trusted network path and require access to the decryption keys to process encrypted data. One of the benefits of using AWS is that our services are also built for integration. You can use several AWS services together to provide the most secure environment for your data and resources. AWS customers are able to tailor or harden the configuration of an EC2 instance, Amazon Elastic Container Service or Amazon ECS Container, or AWS Elastic Beanstalk instance, and persist this configuration to an immutable Amazon Machine Image or AMI. Then, all new virtual servers or instances launched with this AMI receive the hardened configuration, whether they are launched manually or through automatic scaling. AWS develops purpose-built security tools that can help you to automate many of the routine tasks that security experts normally spend time on. You can automate security engineering and operations functions by using a comprehensive set of APIs and tools. You can fully automate identity management, network security, and data protection and monitoring capabilities, and deliver them by using popular software development methods that you already have in place. In the AWS cloud, you can also turn your infrastructure into code. You can automate the creation of trusted environments to conduct deeper investigations and forensics. You can run incident response, simulations, and use tools with automation to increase your speed for detection, investigation, and recovery. By automating deployment and maintenance, you can remove operator access to reduce your attack surface area. AWS provides services and features that help you to protect your data at rest and in transit. Safeguards include fine-grained access controls to objects, creating and controlling the encryption keys that are used to encrypt your data, selecting appropriate encryption methods, integrity validation, and appropriate data retention. Another best practice to help you manage protection is to implement a tagging schema to classify your data into sensitivity levels. Construct mechanisms to protect data in transit, such as using virtual private network or VPN, and transport layer security or TLS connections. Even with mature preventive and detective controls, you should put processes in place to respond to and mitigate the potential impact of security incidents. The architecture of your workload strongly affects your ability to operate effectively during an incident. Isolate or contain systems and restore operations to a known good state. Put tools and access in place ahead of a security incident, then routinely practice incident response through game days. Let's look at some practices that facilitate effective incident response. First, use detailed logging. Logs can contain important content such as file access and changes. Next, automatically process events and invoke tools that automate responses through the use of AWS APIs. And finally, pre-provision tooling and a clean room by using CloudFormation. This provides the ability to carry out forensics in a safe, isolated environment. Reduce your exposure to unintended access by hardening operating systems and minimizing the components, libraries, and externally consumable services in use. Start by reducing unused components such as operating system packages and applications. Configure security groups and network access control lists, known as network ACLs, in your VPCs to help reduce the attack surface of your applications. Certain AWS services, such as AWS Autoscaling and Amazon CloudFront, help applications to scale to absorb common infrastructure layer attacks, such as UDP reflection attacks and SIEM floods. By using techniques such as automatic scaling, you can absorb larger volumes of application layer attacks. The key takeaways from this section of the module are the design principles for security in the cloud. Apply the principle of least privilege, enable traceability, secure all layers, automate security, protect data in transit and data at rest, prepare for security events, and finally, minimize the attack surface. Thanks for watching.